our notes, we're going to do place value today. And place value helps you with adding and subtracting numbers. And each of these numbers means something. Like when you have that 4 there, that's 400. The 5 is 5 tens, and the 6 is 6 ones. And actually, some people have argued that depending on the language that you learn and what that language decided to do for numbers, some people can do better at math than others. Okay? You know what was one thing that was probably hard for you when you were really little? Was counting past 10. Because after 10, some languages say 10 and 1, 10 and 2, 10 and 3, until they get to 20, and then they don't have a special word for 20, they just say 2 tens. Like, if in English we could have said 400, 5 tens, and 6 ones, maybe things would be easier. But instead, we don't say 10 and 1, we say
400.
What's 10 plus 1?
11.
11, right? It's a weird word. And because it's a weird word, it makes it harder. Do you know what the French word for like 80 is?
Taliban.
And do you know what does that translate to?
80.
It's 80, but what's the first word? Which
four.
means?
4.
And what's the second word?
20.
Their word for 80 is 4 20s. Which is true, right? If you took 20 plus 20 plus 20 plus 20, that makes 80. But that's kind of, so sometimes the different languages you learn can make your math maybe easier or harder when dealing with stuff, okay? But, place value. So every time you have a place, it's representing something. So the 4 is in the hundreds, the 5 is in the tens, the 6 is in the ones, and same thing in decimals. The first decimal place is your tenths. The second one is your hundredths, and your third one is your thousandths. So technically, 0.123 is 1/10 plus 2 100ths plus 3 1,000ths. Or, if it goes all the way to thousandths, we could change it to a fraction by saying you have 123 thousandths. Awesome.
Or can you just
Perfect.
perfect now?
Go.
No, we have a few extra.
Good. There's some that haven't come yet. And this, I think, in the English language is a little bit crazy. Isn't it crazy that they put the TH on the end of the word? Like it's kind of hard to say some of those words. Like hundredths. It's like,
You said un song.
what's that?
Un song. 100.
Yeah.
100.
100ths in French. But that TH at the end makes it kind of like, that would be a good puzzle. Give someone that and say, I want you to find a word that has those 5 consonants in a row. Think they'd come up with it?
Not for a while.
Not for a while. Anyways, sorry, getting off topic. We don't need to make puzzles. We're doing math. So those are our place value. So someone gave you 5 $100 bills, 7 $10 bills, and 3 loonies. How much money would you have? Write your answer on your paper. Someone gave you 5 $100 bills, 7 $10 bills, and 3 loonies. How much money would you have? Better question is, how can you convince someone to give you 5 $100 bills? 7 $10, this would be a good day, right? And 3 loonies? How close? What number did you get to?
33 or 32. And I'm there, but I don't understand this, so now I have to look.
Did you get 573?
Yeah.
Excellent. So again, this is place values. These are your $100 bills. These are your $10 bills. These are $3 bills. They're all holding the place value. Where do things get a little bit trickier with money is when you have some things that are like in $20 bills and $50 bills and $5 bills, then you have some more adding that you would need to do. How to convert decimals to fractions, and I kind of looked at this already a bit, but 1/10, which is 0.1, is exactly 1/10. That's what 1/10 means. So fraction-wise, if someone says 1/100th as a fraction, that's 1/100 as a decimal. 2 decimal places goes to your hundredths. So decimal 01 is 1/100. You're giving up for that.
Yeah, I just know that I'm gonna get so locked in on this everything.
You can come back at them.
Yeah, exactly. Might have to take it home. Cause there's like, at one point, at least for now, it disappears, the
Level
numbers
2.
disappear.
Okay.
Perplexus rookie.
Yeah, you're rookie mode.
Do you do this very easily?
It's not bad. It's not good. You can't go too fast. You have to concentrate.
Yeah, but it's at 38. Wait, you know?
So anytime you have a decimal, you can take each part and change it to a fraction, or you could take the whole thing and say, I went to the hundredths, so I can make it over 100. We're going to find out when we get to our fraction work that often, if you don't have a calculator, working with fractions is usually easier than working with decimals. If you have a calculator, then the decimals are usually about the same as the fractions. So anytime you have a decimal, you just have to say, you have to go, I know these are tenths, I know these are hundredths, and the next one, the third one is thousandths. The fourth one would be 10,000ths, then 100,000ths, then millionths, and so on. And anytime you can take a decimal, you could change it to a fraction. So I want you to try changing each of these on your own to fractions, and I'll put up the answers in a second.
Oh, just show me the numbers. Okay, now I see 32.
You get 53 over 100 for the first one. If there's a negative, you can put the negative on the top with the fraction if you'd like. That one will be negative 6 over 10. And the last one, negative 912 over 1,000.
I feel like it definitely wants me to guess 33.
Oh, there's no guessing on that. Try the next two. No, I think you should be able to do that one. You always know which way to do. did. Did you get 1 out of 10 on this one? And 32 out of 100 on that one. All right, we're going to finish this page, and that's all we'll do for notes for today. So, what do we got left on this page? Next thing is dealing with some fractions. Now we know how now to change decimals to fractions. And there are fractions that are called proper fractions, fractions that are called improper fractions, and fractions that are called mixed fractions. Proper fractions are when the top is smaller than the bottom. Because when you think of a fraction of something, you think of something less than the whole thing. So normally when we talk about fractions, we're thinking about something less than the whole thing, right? I've got a fraction of what I used to have. If someone uses that English expression, you have less than what you used to have, usually, because they're talking about a proper fraction. Whole. One of my hobbies is changing fractions to decimals. Does anybody know what decimal 1/2 is? Which is like usually the first one you know.
0.5.
0.5. I like it. I like it. 0.5. So I'll just put that in just for fun. Next, I have an improper fraction. An improper fraction is when the number on the top is bigger than the number on the bottom. In a fraction, we have a special name for the numbers on the top. We have a special name for the part that's the top, and a special name for the part that's the bottom. Do you remember the names of fractions?
Numerator and denominator.
The top part is your numerator. The bottom part is your denominator. Excellent. So when your numerator, the top part, is bigger than your denominator, we call that an improper fraction. And improper fractions, you can change to mixed fractions. 4 divided by 3 is the same as 1 1/3. Do you remember how you figured that out? You would have done this in middle school. Like if I had 4/3, how do I know that it's 1 1/3? If I had another one, if I had 8/3, how do I know as a mixed fraction this is 2 2/3? What did you do?
Make like whole numbers.
You make whole numbers. So like, how many 3's fit into 4? Only 1. How many 3's fit in 8? You can get 3, you can get 6. If you skip count, can you get to 9? No. You can get 2 full 3's out of there. And then what's left? After I pull out 1 3 in there, can you see that you have 1 left? So you pull out 1 set of 3's, and you're still left with 1. So we'd say this is 1 1/3. In the 8/3, I had 2 sets of 3's, which makes 6, right? How many are left if I take 6 out? I'm left with 2. So this becomes 2 full 3's, and then another 2 left, so 2 2/3. So sometimes you have to do this. Switch this way to this way, and sometimes we'll have to work backwards. So I'm going to give you one just to try here. I'm going to say 3 2/5. Can anybody work backwards for me? What do you think about what that would be? Matthew's got an answer. I'll just wait a second, let everybody think about it for a second. See if you can remember how you change that back to an improper fraction. Everybody's had a chance to think about it. I'll give Matthew a chance. What do you have?
17/5.
17/5. Well, that 3 with the 5's, if you have 3 5's, it makes sense that you'd have 15. 5 plus 5 plus 5. So this represents 15/5, and then you have another 2, so you get 17 in total. So it's important to be able to work forwards and backwards. These ones as decimals are 1.33333333. Threes would go on forever. Did your teacher ever show you how to write that down? Because it's really annoying if you'd have to write threes forever. You'd probably die before you finished.
Put a line over it.
Yeah, I love it. I've seen a line over it. Sometimes people put a dot over it, something over top to say, hey, it keeps on doing that over and over again. And this, for me, is one of the reasons I like fractions sometimes better than decimals. Even if I had a calculator, you know how long it takes to type in threes forever on a calculator? I eventually just say, okay, I think I've done enough. I'm going to move on and do the rest of my math. But if I can type 4 divided by 3 on my calculator, then all those threes are automatically there, and that's kind of nice. Okay? So, this is what we're talking about. Changing from that mixed fraction to an improper fraction. Write 2 3/4 as an improper fraction and as a decimal. Okay? So we already talked about what Matthew said there is that he went, I have 2 full ones, 2 times 4 is 8, plus 3 more pieces, 8 plus 3 is 11, that gives me 11 over 4. Now, personally, when I think about fractions, and I like to sometimes draw pictures to think about fractions, and if I'm going to draw pictures representing fractions, my favorite thing to use is chocolate bars, because it makes me happy. So in this 2 3/4, what I imagine is I have 2 3/4 chocolate bars. I can draw that like I have a full chocolate bar, another full chocolate bar, and then I have 3/4 of a chocolate bar. And what I imagine, if the number is 4, I imagine a chocolate bar that when you take the wrapper off has 4 pieces. What does that make it? Is there one? Can you think of one? I think I've got one in my head. Is there a chocolate bar when you open it up only comes in has 4 pieces? Which one?
Did you get that?
Kit Kat, right? So if I'm going to make this a Kit Kat, I'm going to actually redraw this last one because I drew it wrong. Because Kit Kats aren't wide, aren't they? Like this way? 1, 2, 3, 4. They'd be like that, right? And the next one be 1, 2, 3, 4. And if I had 3/4 of a Kit Kat, does it make sense that I would have only 3 out of the 4 pieces? This represents 2 3/4. Sorry, I have to make it realistic. There we go. Could have got my crayon out. There we go. Coloring. Sorry, my coloring is sort of at grade 2. This, I'm going to do grade. Oh, this looks like I'm at grade 4. There we go. Nice. So, when you're talking about a mixed fraction, you're talking about wholes and a part. I have 2 full chocolate bars and 3/4. That's when I say I have 2 3/4. When I'm talking about the improper fraction, someone's like, well, how many pieces do you have left? Your pieces are your quarters. Can you see easily here that there's 11 pieces left? You have 11 quarters left. Now the mathematics, I mean, if you want to draw chocolate bars every single time, you can. That's perfectly fine. However, the mathematics says, when I have 2 3/4, well, I can do 2 times 4. These 2 together tell me 8 right away. That's my 2 full ones. That's going to be 8 pieces. Plus, I have 3 more pieces left. That gets me my 11.
Come on, I love that this shows why.
It's not just doing it, right? Because sometimes you're taught, oh, I have to do 4 times 2 and add 3. And if that, I'm trying to remember it. And it's hard to remember something if it doesn't make sense to you. If you're just told, do this over and over again, you're like, I don't know what. And then by the end of grade 9, I could teach you 400 different things you have to do in math, and your brain is gonna be like, I don't know which thing to do when. The more things that we can see and go, oh, that makes sense, then you're going to remember. Okay? So that is the idea, and I like doing it in chocolate bars. And then I have to think about, I have to try to find chocolate bars that have different amounts of pieces. It's like, is there any chocolate
The
bar
Milky
that
Way.
comes in 2 pieces only?
Kit Kat.
I guess the mini ones, right? You get a little mini, that would work, I like it.
He knows his job.
He knows his chocolate bars. I guess probably a mini, the little tiny Aero bar too only has 2.
No, they have 3.
No, they have 2. That's my favorite. Those little mini ones. Like, at
Mini-
at
oh, yeah,
Halloween,
the mini.
at Halloween, you're not
Are they
getting
like
an Aero bar
square?
from my house. I'm gonna steal them all. See?
There used to be like O. Henry's with
Oh, Henry's. Oh, Henry's.
4. With 4.
4. It was like one big thing.
It was like a one long, and then it was like they had 4 minis
Oh.
in like a white casing.
Yeah.
If they have chocolate without any pieces, like where it doesn't split off.
Doesn't a Crunch bar just say Crunch on it? It's like one big thing.
I've never had a Crunch bar.
Do they still make them?
Yeah, they do.
Okay. But is that tr- like you open it up and it just says Crunch and it's like one big thing, right?
I think so,
It's
yeah.
a 1 piece. What about 3 pieces? Okay, now we're thinking chocolate bars. I don't think we're doing any math anymore. How many letters are there in total? It's a 9 piece. That's pretty cool.
Did you look up?
No, I can spell it on my fingers. There we go. Okay. Changing from an improper fraction to a mixed fraction. So now, this 13/5, if we're thinking about a chocolate bar, you have 13 pieces. That's how many chocolate bar pieces you have. Apparently, when they write 13/5, every time you have 5 of them, it would make 1 chocolate bar. So if I draw this out, how would I draw that out? And now I'm stuck. Do we have a 5-piece? Is there a chocolate bar that has 5 pieces?
No, that doesn't have to be chocolate.
Okay. I feel like I want to Google it right now, but I will just. So what I'm going to do is I'm going to draw a chocolate bar with 5 pieces. 1, 2, 3, 4, 5. Another chocolate bar with 5 pieces. 1, 2, 3. That comes out to 10 pieces. Can you see that I would have
3.
3 pieces left? Bear with me. I got it colored in so it's realistic.
The detail.
Oh yeah, it's all in the details. There we go. Now it looks like chocolate bar. Not big piles of poop. Okay, I muted that. That's not on the video. There we go. I see now that 13 over 5 is going to be 2 3/5 from the picture. Mathematically, now that I know how the pictures work, I'm like, okay, so when I have 13/5, I'm like, how many 5s can I put together and still stay under 13? I can do 2. I can't do 3 because 3 5s is 15. I don't have enough to make 3 full chocolate bars. Right? But I could glue some of them back together and make 2 full chocolate bars and have 3 pieces left over, which means I have 3 because this one's missing and this one's missing for that. That's the wrapper. Those ones are missing. They were eaten already. That is what would be left. All right. So that's where we're gonna stop for today.